Hello guys and welcome in this new tutorial. We are going to continue exploring the concept of voltage, current and resistance. So let's look at this picture. What we have is a voltage source and it is rated for 5 volts. Let's assume that it is pushing charges throughout this closed route. The brown device on the right hand side is a resisting element. So while the charges are trying to flow throughout this gray route, this resistance is going to make the movement of these charges slower. So if we compare the potential energy of the charges before they hit the resisting element and after they hit the resisting element, we will see that there is a potential difference. We call it voltage drop. Now, the amount of charges that are passing through this road per time unit is called current. The higher the resistance, the less the current is gonna be. It's like the flow of the charges decreasing. Now, as we can see in this picture, the higher the voltage, the more current we will have. Because think with me, I is equal V over R. The larger the V is gonna be, the larger the current is gonna be. So more charges are going to pass per second. Now let's take an example by calculating the current for both circuits. As we can see, the resistance is the same for both circuits. They are both 1000 ohms or 1 kilo ohm. However, the first circuit has a larger voltage source than the second one. The first one is 10 volts, the second one is 5 volts. Now we know that V equals I times R, or we can rearrange it to have I equals V over R. So for the first one, we'll get 0.1 amps, and for the second one, we're going to get 0.05 amps. So here we have the same resistance, but a different voltage source values. It means we will have different current values. Now this will lead us to another concept, which is power. Power is the amount of energy consumed per time unit. The higher your voltage and current is, the higher the power consumption is going to be in your circuit. And power as a formula, or one of the formulas, is the voltage times the current. Now let's take this example. Usually power supplies are rated per their output voltage and the current they can supply. So if you want to know the power consumption of any power supply, all you need to do is to multiply the output voltage by the current it can provide. This can be applied on any type of power supply, from industrial ones to your phone charger to whatever device that supplies power. So this very basic example is giving us a DC power supply with 5 amps output current and 24 volts output voltage. Now these ratings are very common in industrial automation. You will see these power supplies everywhere. They are used to supply the control units of the electrical panel you're trying to design. So we will find the answer simply by multiplying 24, which is the voltage, times 5, which is the current, and we will get 120 watts. Since watts is the unit of power.